All right, apparently, doing a live recording is a lot more difficult than I thought it was, and as such, we will be continuing this tutorial fully recorded ahead of time. I do plan on doing some live stuff where people can ask any questions if they get stuck, but the vast majority of this will be recorded ahead of time. And as I found it to drastically increase quality to the point where I would not listen to myself talk live. All right, so for today, we will be continuing on to step one. We need to create our step one file, which is called step one read print. You got to make sure you get the names correct. It's on the Mal website, so it shouldn't be too difficult. We make a new full file in the bin folder because this is a binary, and it's step one read print, and we add it to Git, and then we what was that thingy? Yep, added that. And we need to copy everything that we had over here into the next file. We're going to add more stuff to it, but we do need to copy the old stuff. The reason why there are multiple binaries is just for the testing situation and to make it multiple steps, but each step is building on the previous one. We add a reader file in the src folder. This is not a binary, so it does not go in the binary folder. Reader, add, and attach file. We attach it to the lib.rs by adding mod reader in the lib.rs because this is part of our main library. And we go to our cargo.toml and we add the Regex library. So under dependencies, you just have this syntax, choose the latest option. If it doesn't auto-complete it like mine, just do the exact option that I chose. It really shouldn't make a difference. Libraries are stable enough to handle stuff like that. Now we will run the program again to get it to compile that library so we have access to it. And we will go to our reader.rs and fill out the stubs of the functions that we need. So we need a struct called reader. We will add the information to the struct later. We need a function called, again, this is all on the website, so if anybody wants, next time I can put this up on the screen so that other people can see it. I just felt that it would be annoying to people, and you can just go on the website yourself. So we have a function called next, and this takes in a reader. So or we'll call it reader, and goes to token to do. A token is, I believe, type token is equal to string. We can get rid of this and just do, we can call this a string instead. And means the same thing, but for some reason I like doing this. Type token is equal to string. Actually, let's get rid of that. Why make it more complicated for other people just because I like something? Then we need a function called peek, which does the same exact thing. Takes in a reader object and goes to a string. And once again, we will annotate it with to do because we don't know exactly what we're putting in that function yet. And we need a function called tokenize, fn tokenize, and this takes in an input string, text, and this goes to a reader object to do. Then we need, actually this should be, I'm an idiot. It should be part of these are methods on reader. So this should just be impl reader. This is basically saying we're making methods for reader. So and instead of it being reader, this is just self Now we have our next function. We have read form, which is another function on reader. Read form. And this goes to unknown. I don't know what it goes to yet. Oh, we're going to define a new thing called types. So we go to our src, new file, types. Go back to types. And we're going to have one main type for a program. And this is going to be enum type. Enum mount type. I will explain what an enum type is in a moment. I'm just right now filling out all the function steps so that we can kind of like get a higher level view of what's happening in the program right now. So we go back to our reader, and this goes to mount type. Well, what did I call it? I called it mount type. Why is that not importing? Oh, it automatically imports. I don't need to import it myself. And again, to do. And fn read. Actually, read form. Then we have read atom. Self mount type. And fn read list. Again, self goes to mount type. This isn't like I'm just literally copying off the website for now. So I will explain everything as we go along. So what else do we have to complete today? We're gonna need to edit the read function later on. And okay, these are the functions that we will be working on today. Let me add the to-dos over here so it can compile. To-do is a macro, which basically allows you to ignore the implementation and still have it compile. So I'll run it now and it will compile. Not accessible. Do I need to make it public? No, I just have to import it. Okay, now it should compile. Okay, that works. The first thing that we need to do is parse string in a manner which makes it useful to us. And what we want out of this step is to kind of separate stuff into meaningful categories. So for example, let's say I have the following mall code. So hello world 455 HSDF or whatever, and if H and this and so on and so forth. Let's wrap this in a string just so that we can be clear that this is a string. And get rid of that. Okay, that should work. Now, we could, of course, try running our parse algorithm on this data. But that's not very useful to us. So instead, we want the data to look like this. Hello world. That's one piece of information. And then we have another piece of information, 545. Then another piece of information, BSD. Then another piece of information. In other words, we want to clump up our blocks into small, meaningful data components that allow us to build our expressions easier. I'm not exactly sure of the exact theoretical underpinnings of why we want to have a tokenized stage and a parsing stage. And there are algorithms that will do the tokenizing and the parsing all together at once. But in general, most programming languages do you tokenize first. It means you just do a very simple passover. This is not there's no sort of recursion happening here. It's all perfectly linear. We're just going over and kind of separating out our data into meaningful blocks. So that's what tokenize does. Our tokenize function is taking the text input and giving out a list of strings where each string is a meaningful block that makes sense to us. And normally, normally the best way to tokenize is to use a very simple for loop or a while loop, depending on your choice of poison. And I'm not doing this here. Why? First off, it is a very boring task. It's not hard. It's not interesting. Number two, I don't exactly know what tokens we're going to need for the other part because it's not specified on the mal webpage. All they give you pretty much is just the regex. So the way this project does parsing, does the tokenizing, is by using regular expressions. Regular expressions essentially allows you to run over a string and build meaningful data sets over it. Meaningful smaller strings out of it, using captures and fancy stuff like that. This is not how you should be doing tokenizing. If you're doing tokenizing for your language, do not use regular expressions. Regular expressions are a terrible idea. However, we kind of have to over here because we're following along with this tutorial. And again, if I ever maybe towards the end, we will actually replace regular expressions with our own tokenizer or lexer. I'm not exactly sure what you call it. Over here, we're calling it a tokenizer. So after we do that, after we make our data meaningful in a way that's usable, we now have to parse it. And this is what this is doing. It's parsing it. All these functions are parsing. Now, what's our reader struct? Our reader struct is going to store. We have what is it going to be called? Our tokens, which is just a vec of strings. And then we have our, not pointer, we have our index, which is a U64 that allows us to know where we are in our tokens. So what Next is essentially doing over here, and then our goal is essentially we are going to be iterating over every single token and doing something with it. And the reason why we need to use a reader struct or an iterator is because we can't use a while loop. You're going to see why we can't use a while loop because we're going to be doing lots and lots of recursion. And we could technically we can just constantly make the tokens smaller, make the vector smaller by popping things out from the beginning. That's not really efficient, but we could just reverse the list and then pop out from the beginning. But it's a lot simpler just to use an index and constantly point to specific parts of the string. And specific parts of the vector. The first thing we need to do for tokenize is to get our regular expression up and running. So a regular expression starts out as just a string. Let reg string is equal to, and this is how you do a raw string in Rust. It's just R and this dude. I don't know what that's called. It's called something presumably, and the things inside of it goes inside of these two apostrophes. And you go to the mal webpage. I will do that right here, and you copy the string and put it inside here. Now, once we do that, we need to turn this string into a regular expression. And the string is technically a regular expression, but a regular expression is like is a series of structs that do transformation on other strings. So we need to turn this into into a regular expression. So let reg equal regex. This is why we imported the regex library before. If you haven't done it yet, go to the cargo.toml and do it. Regex dot new. Did I get the name wrong? Is it regex? Yes, it's regex dot new. And then we feed it our reg string. So this is creating a new regex from our string. Now we need, so now that we have that, we need some way of iterating over the results of our regex. So we for I in reg the iter captures dot iter. What is it called? Actually, okay. Here's another example of error handling. So regex.new does not return a regex, even though it looks like it returns a regex because it's called regex.new. Instead, it returns a possible string. So what we're going to do, this is our first example of error handling. I feel like I keep putting it off for too long, so that's not a good idea. Even though we should really use expect like we've been using previously, instead we are going to use match, because match is how error handling in Rust finally begins to make sense. So we're going to go match, and then we're going to take this guy. And so as you can see, match is currently red because it's saying we haven't handled all possible options. So Alt Enter, add remaining patterns. So, okay, we're going to call this R, and we're going to call this E, error. Actually, we don't need to call this anything. So now, regex.new returns a value that is either a regex, or, how do I do a comment again? What happened here? So I have either a regex or an error. Now what I'm doing over here is I'm saying I am matching on that result. I am matching on the thing that is returned from this function. Now I'm saying, okay, if you give me an okay value, if you give me a value that's good, I want you to return that value for me. If you give me an error, because this error should never really happen, because the only reason why a regex is going to fail is if I give it a bad string, and this string is decided at compile time, and this string should always work. If it doesn't work, then our program is bad. We're going to call panic. This should be, this is a macro, again. So we're basically saying, if this is an error, otherwise, return the okay value, which is reg. We can call it anything we want. We can call this regex as well. And this would just be returning regex. Now, one of the big rules in Rust is that whenever you have a match expression, all possible outputs of the match expression have to be the same type. Now it's a bit confusing over here. Why are these two the same type? What's type regex? Regex is type regex. What's type panic? Well, as far as we know, panic is of type void. There's nothing here. But it turns out that, what's the reason why we require all match arms to be identical to each other? It's very simple, because we want the value that's returned to have a type. And the only way the value that's returned from the match can have a type is if all arms of the match statement have the same type. But this is not a concern here, because on this error, when it's an error, we just panic. So it's never going to return a type that doesn't match with regex. So therefore, Rust lets us get away with not including a return value for when we have an error. And now, instead of having beforehand when we had just regex.new, we had it's either a regex or an error. Once we do this, it's of type regex. Now this is identical to this code. identical and better actually to do this. This is when you're saying I dot expect. So dot expect is basically matching on the on the value that's returned from regex.new, which is either an error or a regex, and then saying if it's an error, crash the program and output the following error message. The regex failed. I know I have very original error messaging. And otherwise, what it does is it returns the regex itself. So all of a sudden, while beforehand, let's get rid of the match statement. This match statement is not supposed to exist. While beforehand, if we get rid of this, we have regex, a result regex error, which means this value reg can either be an error or a regex. Now we're saying dot expect regex failed. Now if you look, it can be a regex because we've already taken care of the error option. This can no longer be an error because if it was an error, it would have crashed the program. Again, this is still not a full explanation of error handling. Error handling is difficult to understand, so I'll do my best every time error handling comes up to come up with the same exact explanation and hopefully drill it into your heads so that it makes sense. If I'm over explaining it, please tell me. That definitely will happen because this is something I struggled with when coming to Rust. So I'm just assuming this is something everybody else is struggling with. All right, now that we've done that, we need a way of feeding. We're now going to feed our text to our regular expression, and we're going to do that with a very basic. We do let our result equal reg dot captures iter. This is the function that we're going to use. It basically gives us an iterator over the captures. It gives us an iterator over all the captures that is done in this string. I believe this is the function we're looking for. If I am wrong, we will find out pretty soon that it is the wrong function. Now we have to iterate over that function. So we can go for capture in result. We also, this shouldn't be called result. This should be captures. Captures in captures. And we need our result variable, so we can add so let mute result equal vec. So we're creating a new vector. And then we're going to add, we need to make it mutable because we're going to be adding stuff to it. And then for every capture in captures, we're going to do, let's annotate the type so it's clear to us what's happening. You don't need to annotate the type. It's just easier. So this is just going to be a vector of type string. It's easier over here because I just want to make sure that captures returns the right result. So result dot push capture dot. Okay, now I need to figure out what type we need. I'm gonna assume it's captures dot get. Captures dot get I dot get name. I'm gonna assume it's captures dot get one because there are multiple captures, so we need to figure out which capture we're gonna get. This might completely error out, and this is of type option match. This, based on this regex, this is not always true, but based on our current regex, it should always return a capture. So I'm just gonna, again, dot expect should have returned the capture. This isn't all, if it doesn't, it's a bug. So I'm not gonna handle the error. I just want it to crash and tell me if the error occurred. Should have returned a capture. Okay, this should still have worked. Found match. Match should be of type string though. Match is of type string. Why is this being unhelpful? Is there a way of .to owned? No, it's a match of type T. Then how am I able to do? Okay, they want us to do as stir .to string. That doesn't help. Oh, now yeah, that works so far. We need to return the reader. So we need to create the reader. This code is not correct yet, but let's just get it to compile. Reader, so return reader and fill out all the fields for me. This is just going to be the result, and this is index of 0. That's what we want. Okay, compile, and let's see what the problem is with our program. Use of unstable core panic. Oh, we can't use panic for reasons, but we just use it for an example. Okay, now we have our first problem. So the regular expression wants a type of type stir, and we've given it a type of type string because that's what we take in from tokenize. And the reason why we take in a string like that from tokenize is because wait, why do we want to take in a string instead of a stir? Because it would complicate a lot of stuff. I'd be curious to test out like whether it would be possible to just take in a stir. The reason why I'm like kind of hesitant to do that is because we're kind of taking in from the user. We're taking in a string from the user. And then we're passing this string around throughout our program. This string doesn't have a static lifetime. And the second you don't have a static lifetime, using stirs can start becoming really annoying. We'll try turning this into a stir. It might not work, but we will try. Text at stir. This is going to make our whole program a lot more complicated though, because then if we have a stir here, then all of a sudden reader needs to take in a stir. And it has to be a vec of stirs. And which means the vector doesn't contain the stirs themselves. The thing that contains the stirs is the thing that's creating the reader function. So now all of a sudden reader has a lifetime. And then everything that returns from reader is going to have a lifetime. Unless we completely implement copy, which is, I guess, what we're going to have to do. Let's try doing everything with a stir and seeing how much we hate ourselves. So this is still not going to compile. Okay, it did compile. That's not good. Why did that compile? This is a token of result. Oh, because we call it to string here. We don't want to call it to string anymore. Then this should be a vec of type stir. This might very well completely and utterly fail. Then, as you can see, now we need to turn this into a stir. And the second we turn that into a stir, all of a sudden we have an issue. We have a giant, massive issue. We have a lifetime issue. So as it's telling us to annotate our lifetime. And okay, so what exactly is a lifetime? So as I explained before, variables in Rust hold values. So when I go a equals 1, a equals hello world, you can conceptually think of it is that a is storing the value hello world. Now when I call b equals a, what I'm doing is taking the value a is storing hello world, and now b is saying, okay, a, give me your value. So a gives b the value. And now b is storing hello world, and a is storing nothing. So that's how ownership works. Now what are lifetimes? So lifetimes happen when instead of saying b equals a, we say b equals at a. So b now references a. So b is saying The only thing I know is that I'm pointing to whatever A is pointing to. So meaning if A owns hello world and I'm pointing to A, now I also have hello world because that's what I have the same thing that A does. Now let's say A later on goes A equals not hello world but dude. Now all of a sudden since B is pointing to at A, now and A is now dude, now B is also dude. Uh so So now what happens if I do something like C equals A? Now, as we already know, C is stealing the value from A. So now A has no value. But now we have a problem because B is still pointing to A and A has no value. So now B has no value too. But so what is this? What's happening here? So what's actually happening here is that we're saying that B has the same lifetime that A has. Meaning B lasts for as long B is a valid value as long as A is a valid value. The second A is no longer a valid value because it doesn't have a value associated with it. B is no longer a valid value because it's pointing to the value that A has, and if A has no value, then B has no value too. Now, what is the lifetime? What is this lifetime that I'm doing that I'm adding to this struct? So reader contains a vector of stirs. Reader contains the vectors of stirs. Now stirs are references. Stirs don't have a value. So tokens, the strings within tokens are are not stored in the tokens. They are stored in other variables, and we don't know what those variables are. So what we're saying over here is that this reader, the lifetime of the reader, lasts for as long as the lifetime of the strings within this vector. So if this vector dies is no longer usable in 2 hours from now, then this reader is no longer usable. And as long as these tokens are readable, are usable, then reader is also usable. And we don't have to keep track of this, but the Rust borrow checker is very kind and keeps track of it for us. Why would we ever do that? It's efficiency. At least we believe it's efficiency. And uh, and especially in the case of Regex, over here, this library uses stirs. So there's a cost from going from stirs to strings. There's a cost from going from stirs to strings. You can go from a string to a stir for free. You can't go from a stir to a string. So what's happening in this Regex thing is it's outputting stirs, and that's why would we? No, there's no point. What am I doing? Why would I add the lifetime here? This is just adding to making things more complicated. I'll leave in my explanation because I think it's a good explanation, but I just realized it wouldn't end up being the same. It wouldn't speed up the library because we either need to turn it into strings later on, and we're getting in a string. So why would we just accept the stir? Like it's the same speed. Why are we complicating things for no reason? I hate myself sometimes. This is just a string. But this explanation will be important later on, so I will not delete it from the video. But and next time we come up to references, I will explain it. I follow the school of explaining things 100 times because I believe that's the easiest way to learn. I don't know what I was thinking. Sorry about that. And this over here we call text dot stir. Now this doesn't cost us anything. Why doesn't this cost us anything? Because you can go from so stirs are basically, you can think of stirs as references to strings. They're not really references to strings. They're more like look-ins to strings, but you can think of it like that. And so I can always take the string. I can always take a string and then turn it into a reference to a string very easily. So I can just pass it text.ster. And the only thing that's annoying is that when it outputs something, actually it might be faster. It's way too complicated. There's no reason to hurt ourselves. Okay, this should be just a vector of strings. Actually, I have to leave that there, and this should be a vector of strings. It just makes it easier. I don't know what I'm doing. It might be faster, but I'm not gonna spend the time doing it. It's the tokenizing phase. It only happens once. It doesn't have to be. It doesn't have to be lightning fast. Dot to string. Is there another way instead of aster? Like, is there like a direct? Is there something else that does anything with it? Not really. I don't know what these functions do. So I'm just going to go with Esther and dot to string. And there's a tiny cost associated with that we will have to pay because I am not doing something more complicated for 2 seconds worth of speed. Now, okay, what else do I have to do after this? Can I test the tokenizing function? Can I test? Yeah, let's test the tokenizing function. So we go to our step 1, and within our rep, we will call. So instead of calling so where do I want to call it? Let's call it right over here. We'll get rid of rep. Instead of calling rep, we will just call we will call tokenize. Do I need to make it public? Yes, I forgot to make it public. Tokenize pub crate. It actually makes no difference to add the crate, so let's just add the pub for now. Then we go to. I should probably just add a testing function, but for now I'll just do it the annoying way. Tokenize. Did I call it something else? Reader.rs? No, I called it tokenize. Standard input. Buffer. Oh, that's the issue. I can't use it because I need to make my reader public. And I should just use a test. I'm gonna the Google Rust boilerplate. Rust test. It's just a bunch of boilerplate that you have to remember, and I have the memory of a turtle. So it's mod test use super test use super, and then this guy test, then fn test tokenize. What are we testing exactly? I'm turning on my this guy for that because it does these kinds of things really well. Let text equals to string. That's what we want. This is not what we're gonna get. This is what we want. This should be, these should all have to have a to string in it. Reader declared as private. Oh yeah, let's get rid of this. Cannot find, yeah, this is gonna, let's put this back to rep before. No, I'm supposed to run I'm supposed to run this. I don't know why that works. That should not work. Test passed? Why would that pass? These are strs, not strings. Maybe assert equals works like that? Let me print the result just to make sure I'm not hallucinating. Print result. Oh, we need to add debug. This is just the derived macro, so what we're doing over here is we're derive debug. We're basically saying, hey Rust, I know you know how to figure out how to write a debug function for yourself. Debug is just a print function. It's the standard. It's a print function that works for pretty much all structs. So we're basically saying, here Rust, figure out your own debug implementation. In other languages like Java and Python, you get a default stir implementation. In Rust, you have to derive it specifically. That's it's a more complicated topic for another day for why it is like that. Now we run it again. Now let's see what it prints. Yeah, so this is what we wanted. except it's really confusing to me why it's printing, why it's not demanding that I ask for to string. I guess it's able to compare the two, but yeah. So our code actually works. Now let's make this a bit more complicated with 2.11 and hello. Now let's and yep, that worked. So our tokenizing function is working so far. Why are we getting? Oh yeah, we're getting a bunch of associated functions stuff is never used. So we're done with the tokenizer. And as you can see, that the data that we got out is a lot more usable. It's not perfect, and doesn't have any structure because it's all just like a flat vector, but it's a lot more usable than this unfocused data that we gave it over here. And it also enables a very nice property. When we parse, there's something called LL1, which is when we only have to do one look ahead in order to decide whatever we're doing with the algorithm. LL1 is damn cool, and I believe it's part of the reason why Rust has such good error messaging. I don't exactly know that much about parsing, but like you want your parser to be LL1. Now, until we tokenize, you can't make things LL1. Why? Because you don't know whether something you actually can you make would you be able to make it LL1? Because you'd be able to figure out where you're at. You might be able to. I don't know, whatever the reason is, parsing is it's much easier to parse once you tokenize. And although again, tokenizing is usually a bit longer than this because we normally don't rely on pre-built monstrosities like this. Yes, this is a monstrosity, and I hate myself for if I ever wrote something like this, I would hate myself. Just write a for loop, please. And uh and again, the for loop would be a bit longer, but this gets the job done for us, and I don't know exactly what the spec is, so it's a lot easier to just follow along with this. Now that we've gotten this, we can start parsing. Before we start parsing, though, we need a way of interacting with the data that we have. So we basically want to iterate over our tokens, over the tokens, which are these thingies on the bottom. These guys are tokens. Each one is a single token. We want to iterate over them, but we can't iterate over them using a for loop because we're using a shit ton of recursion. So we need some way of keeping track where we are in the string. And as I mentioned before, we can keep track of where we are in the string by constantly popping where we are in the vector, where we are in our tokens, by popping off the things that we don't need. But that's not how we're doing it. We're doing it by keeping track of an index. We're basically saying this is where we're at in our string. And every time we go further along in our iteration, we just update the index and move it one ahead. Now, we have two functions. We have their next and peep. Did I get that right? That sounds very suspicious. It feels like I got the names wrong. Next and peep. Peep, yeah. That's not. Yeah, that doesn't not work. So next returns. Okay, I am turning this up. Sorry, that's not supposed to be on. Next returns the current token. So tokens. So self dot tokens of self dot index. This is what we want to return. Now we also want to do something else. We want to so let's say let result equal this. Now we also want to, now that we did that, we want to increase the pointer. So we want to say self dot index plus equal 1. Now we want to return self. Not return self, we want to return result. Now what's the issue over here? We can run the thing and it'll give us a nice error message on the bottom. Oh, my bad. This should not be a U64, this should be a usize. Usize is a type of U64, but usize is the general token, this is a general token type. Okay, now what's the issue? Move occurs because value has type string, which does not implement the copy trait. Help, consider mutably borrowing here at self tokens. Then, okay, so what's happening here? Because over here we have a vec of strings, and we're getting oh, that's why we probably should use a stir. Should I go back to using a stir, because at the end of the day using a string doesn't help over here? Actually, what we can do, the best way of doing this would be to no, you can't. Ugh. I'm trying to figure out if there's like an efficient way of doing it, because right now what's happening is, you remember, right now tokens are storing all of our tokens, and is owning all the tokens. So the place where these strings are stored in memory are within the token string. Now, when I call next, I am trying to access these. But the only way I have to access it is by is by is by either taking away the string from the vector, or by getting a reference to it. So I can either make this return at string, or I can do something, or I can break the string inside. I can take out the string from the vector. Now the problem is, if I take out the string from the vector, then there's an empty spot in my vector. And what do I do with that empty spot? So two things can either happen. I can either completely destroy the vector, and what that does is the vector will never be usable, even though I only took away one string from the vector. Because I didn't replace that string and that index is still valid, Rush is like, well, there's a point in this vector that might have an invalid string. I can't let you use this. So the other way of doing it is take the value out and replace it with something else. So we can. I'm trying to think of whether it's worth doing this, because this is a bit complicated, because we're going to be using like some sort of memory function. I'm trying to think if there's a very simple way of there is a very simple way of doing it, and that's by using iterators. Iterators have done all the hard work for us, and I don't want to use iterators, because that would be kind of like, it would make everything too easy is the wrong word. It just like it kind of makes things I guess less explicit, I guess. Three options. So we can either replace the thing in option, we can get a reference to the string, but the problem with getting a reference is that we eventually need to turn it to make it not be a reference. At some point it needs to be a string, because we're moving it along. So at some point we need to copy it. So the question is, do we copy it? Do we do it? If we just get a reference here, we need to do a copy later on, which is inefficient, which is fine. Like, there's nothing wrong with doing inefficient stuff. And for simplicity's sake, I am fine with doing that. But for now, later on, we'll make it faster by replacing with an iterator, and we won't do a replace. So for now, this will just be return a reference to a string, and this will return a reference to a string. And why is this failing now? Okay, now the problem is that we're mutating self, and self has not been listed as mutable, so we need to make self mutable. And okay, don't listen to this. This is one of the most annoying things for us. It's telling us to annotate it with a static lifetime. It is not a static lifetime. Why is this not static? because the string that we're getting is a reference to a string in the reader. This string only lasts as long as reader still is valid. The second reader becomes invalid, our string dies. So we therefore we want our string to only last as long as our reader lasts. Static means it lasts forever, and our string does not last forever because reader does not last forever. So what we need over here is to go, we need to make our reader, we need to give our reader, reader doesn't take, how would I annotate that? I believe something like this. Cannot return value referencing local data self dot tokens. What data is owned by the current function? Oh, okay. So yeah, this is my fault. I was planning on. I specifically made a mistake earlier on to show it, and I thought the borrow checker would be a lot more helpful and say exactly what the mistake was, but it didn't. So over here, as you can see, fn next takes in a mute self. Why is that a problem? Because whenever you take in a value that's not a reference, you take ownership of the function. So let's say there's a value called a which is our reader. A reader equals reader, and then I call a.next. What happens is a is basically, it's a lot easier to understand if you use this kind of syntax, even though it's not valid syntax. Next is taking the value from a and putting it inside its function, and a no longer has the value anymore. Now, what I'm trying to do is I'm trying to return a string that references the value that enters this function. But the value that enters this function never leaves the function because it's here. Because it entered here and we never returned it. So we need to reference it instead. At me itself. Let's get rid of these stuff. It's still not going to work. Okay, what's the issue? Okay, the problem is we need to, let's get rid of this. This is not where we want this. This is just, you always kind of have to guess where you put these stuff. Probably here. Here. Where do I put this? It has to go somewhere, right? Why does it not work? Oh, here. I have to annotate it here. What is the issue? Oh, okay. I don't even need these. It figures them out for itself. That was the only reason why it was giving me shit before, was because I forgot to add that in there. So that works now. So there is a lifetime here. There is a lifetime, but Rust is figuring out for itself what the lifetime is. It knows that if I'm returning a reference to a string, the only thing that it could possibly be referencing, is the thing that I put in the function. So it must be referencing self. What did I just do? And if it's referencing self, I don't need to tell it that it's referencing self. I don't need to tell it that it has the same lifetime as self, because it has to have the same lifetime as self. Okay, now what would peek do? Peek does the same exact thing as next, except it doesn't iterate the function, so it just returns return at self tokens self dot index. Why are you erroring out over here? Oh, same exact issue. I need to make this again. Peek has the same exact issue. If it takes ownership of the value never exists ever again. So I need to take in a reference. But happily, this time it's not a mutable reference. And so same thing, expected string found at string, at string. So this is the simple way of doing it. Again, this should compile perfectly fine. Okay. All right, now we continue on to the actual parsing. And this is not that this is where it starts becoming hard, quote unquote. And the reason is because we're going to be doing a ton of recursion. So first off, what are these things? What is the atom? What is a atom? What is a form? What is a list? So when you most languages have a grammar associated with them. So there are so we start off like what's the most basic thing you can have in your language? You can have uh uh let's say a plus symbol or 1099. You can have a number, you can have a string. These things are the basics. These things are the fundamentals of the language. Like these are the smallest thing you can possibly parse. We're gonna call this an atom. Atom equals simplest thing. So in some sort of like usually there's like a language. This can be an int. This can be a string. It can be a symbol like plus, minus, etc. So these are the simplest possible things that you can possibly parse. Okay, now we can go even further and we can say what's there's also an order of operations. So you think of it like let's say I have uh, uh, plus 1 1 1 plus 1 1. Now when we reach here, because there's parentheses, you always do the parentheses first. You always kind of uh, you always parse these things together. Like it doesn't really matter what's surrounding it. Parentheses mean you do it right away, especially in Lisp. But like if you think of it in math, like BEDMAS, the first thing you process is always going to be uh, parentheses. So these are that's what the last one is referring uh to wait what would read list do? Uh, no, that's not read list. This is so then read form. A form is essentially either an atom. A form is either an atom or a list. Where a list is so what's a list? A list is a collection of forms. A list is many forms. Why is a list many forms? Because a form is either an atom or a list. Is either an atom or a list. And a list is many items. But you can't say that a list is many atoms. Why can't you say a list is many atoms? Because a list can contain another list. A list can contain another list. I hate this confused. I don't know why you call it list when you can just call it a list. Now, what does that imply? So if I just said a list is many atoms, then I wouldn't be able to represent a list containing many other lists as well. So when we say, and we can't say a list is many lists because this is pure recursion. Like it wouldn't give you anything, and it wouldn't allow you to represent a simple list like 1 1 1. So what we need to say is that a list is many forms. And now you're starting to see why processing it requires recursion, because so as you can see, atom never calls anything else. When you're processing an atom, all you do is return the specific type that you're processing. If you're processing a list, that's when things. If you're processing a list, that's when things start getting complicated because you need to recur and process process other lists as well. And it's not just lists because a form can either be it can either be, there are different kinds of lists. So there's like, there's these guys, there's vectors, which is also many forms, which is, so a form is either a list or a vector, and I should probably be using a text file so there's no error, red error stuff floating around. Then maps are equal to, maps are actually not exactly lists, but they're similar. This is many form. So it's basically many tuples where the first part is a form and the second part is a form. I hope this makes sense because this is just like some sort of formal grammar specifying what our language is, and we process it according to this formal grammar. So we have one function corresponding to each of these possible things. So we have a read atom and a read list. So a read atom is the simplest function. You only call read atom when you've reached the end, when you've reached something that is perfectly parsable. Like for example, the number 10 is a perfectly parsable number, and we will only call read atom on that. And therefore, there's no recursion involved in read atom. Read form needs to check whether it should call read atom or read list or read vector or read whatever, read map. So it's going to have a recursive structure of checking the first thing and seeing what it is and deciding what to call. And the hardest one is going to be read list, read map, or indeed read. We might be able to create a generalized version of read uh, specific types because it's going to have the same It's going to be basically the same identical code. But you basically need to call. So you need to constantly, once you call read list, you're constantly calling read form because a list is contained of forms. So in order to read a list, you have to read forms many times until you hit the end of the list. And then the way you start is you recursively start calling, you call read form on the first thing, and it will check whether it's a parenthesis. If it's parenthesis, left parenthesis, then it calls read list, and then it processes everything properly. Okay, now to implement this. So the first thing we're going to do is we will take our reader. This is going to have the same exact problem. This needs to be at mute self because we will be calling next on it, and next requires a mutable variable. So only way we can get a mutable variable is if we take in a mutable variable, and it needs to be a reference because we don't want to destruct the reader variable that we get. We want to keep that variable intact, so it needs to be a reference. So now we need to do match against the first element. So we need to go self dot not next self dot peak. Actually, is it self dot peak that they're saying to use? I mean, I could just do it like it doesn't really make a difference because you're as long as you get the values right, it's equivalent. Yeah, it's self dot peak. So we're just gonna call match on it. Match on self dot peak. Now it's telling us very very helpfully that we haven't completed all the values. If you hover over it, we'll see. Add remaining patterns. You can just do Alt Shift Enter and have that. It doesn't know all the patterns. I am an idiot. There's a very good reason why it doesn't know all the patterns because there are no patterns. So we should just use the if statement instead. So let's first get the value. So let head equal self dot peak. So if now we're gonna check if head equals this, then what are we gonna do? We are gonna call because now if the head is this, then we're calling then we're gonna call read list because we're processing a list. And as you saw with the recursion thing, that means that even though we know we're a form, the kind of form we are is a list. Now we call read list on it. Then we call. So here's the first time I'm going to explain what an expression based language means. So what an expression-based language means is that instead of this is surprisingly hard to explain. Instead of having multiple, instead of doing something like return read list, return self dot read list. Instead of doing this, I can do this. What does this mean? Over here, every single thing in our language is an expression. So the simplest expression we have is 100. This is an expression. We know what it evaluates to. Now, a more complicated expression would be 1,000 plus 1,000. And in Python, you can say something like x equals 1,000 plus 1,000. And that's completely valid. Why? Because this on the right side is an expression, and you can assign variables. You can assign expressions to variables. Now, Russ says it's not just values. It's not just simple values that are expressions. Everything is an expression. What does that mean? So how can if be an expression? So the simplest thing, let's go with a very simple if statement. So we're going to say let expression, let number equal if 10 is equal to 10, then 11, else 10, else 3. Now what we're saying is that this number, this whole thing, this if statement has a value. In this case, the value is 11 because 10 is equal to 10. But if this was 9, then it would evaluate to 3. And the reason why this is valid is because both branches of the if statement are expressions. So this branch is an expression. The left branch is the expression 11, and the right branch is expression 3. And the if statement says, okay, if 10 is equal to 10, then take the first expression. Otherwise, take the second expression. So, and the same thing with a function. And the way you end an expression, the way you, how do you, so expressions continue, right? Now, let's say I got rid of this. This is why Rust makes you get rid of this. Now, at this point in the function, we have a giant expression. And I can do something like, I mean, you can't really do that. You might actually be able to. Dot rotate left. Well, dot rotate, I don't even know what dot rotate would even mean over here. But it's a thing, apparently. Now, because we're at this point in our function, at this point we have an expression, we can do things with our expression and mess with it. And therefore, if I got rid of this, if this wasn't here, this function would return 11. Because our function is one expression, and so we evaluate this expression. This expression evaluates 11, and therefore the entire function evaluates the 11. If we want our function not to evaluate 11, we would have to add this. This closes off the line and breaks our current expression. When you break a current expression, you know what type you get? You get the none type or the void type. So pretty much every type, every empty line, every finished line is void. Now, why does this matter? So we are going to call if head is equal to this self.read list. Now, Rust is telling us there's an error. Why is there an error? Because the second half of the branch, even though there's no second half, but this value, this expression, is only a partial expression. Because if this is not a left angle bracket, then this expression doesn't evaluate to anything. It evaluates the void. And an expression has to be evaluatable to a specific type. So we need to add an else branch. Else self dot read Adam. So we're basically saying read Adam is our last choice. If it's not a list, it must be an Adam. Later on, there's gonna be other options. There's gonna be like a vector and a map. But for now, these are our only two options. And Okay, so now we finished with read form. We need to go on to read atom, and again, the same exact part. Wait, there's actually a mistake here. Um, mm, no, there's no mistake because we haven't advanced it. We're just peeking on it, and now we're gonna continue on to read atom, and we're gonna. This also has the same exact issue that you don't want it to consume the reader, so and it also has to be able to mutate the reader. So we are gonna call at mute self and get rid of the do. And what else do we have to do? Um, so read atom is just a giant if statement. So we get but this time we can do let head equal self dot next. Uh, I'm not sure what's stopping us from. We need a way of stopping this. This should stop parsing at a certain point. Uh, huh. We'll figure it out when we get to it. Then head is equal to self dot next, and the reason why we can do this is because we're always going to be parsing. And then we do uh, we check. So if head is if head so how do we check if it's a we need to check if it's an integer, for example, or if it's a string. So if head dot actually how would I be able to tell if it's a string? Let me check what the value because I don't know what the regex gives you. If the regex gives you a decent value, it should be pretty easy to use. Let's get rid of all these stuff. Should I put this in another file? I'll add another file for later reference if this becomes necessary. It shouldn't, but just like there's no reason not to. File grammar text. Add it to get for all I care. And this, then let's put this in our grammar. But yeah, okay, that works. Now we go back to our reader.rs. That was where we have our first. Wait, how did it show a low? Oh, that is not very helpful at all. Um, no, it did. I need this to be. Let's say this was. Hello, how would that parse it? Oh, that needs to be raw. Oh, whatever. That's what I see to make it raw. Error. Read list at mute self. Same exact reason we have to make this at mute self. That caused the function to fail. I know what caused it to fail, but I just want to see what we got. So yeah, so it saves the strings. I mean, of course it saves the string. I'm an idiot for not assuming that it did. Let's get rid of this. Get rid of these two guys. And the test passes. That's what we wanted. Okay, now we have to so we want to check, is it a string, let's say. So if head dot 0, why is that not working? Oh. If head dot 0, then okay, I can't really continue. Before we continue now, because now we're actually parsing the mount type. Beforehand, we were kind of like letting off the logic to something else. But now we're actually creating the parser, and we need to go back to our type and work on our enum, which is a more complicated topic. I think we did enough for this session, and I will end it here. I'm sad that we didn't manage to finish the entire stage, but I'm not surprised. It's a relatively long uh, top task. And any questions, please feel free to ask. I'll be live streaming at 6 for as long as people are willing, as long as people have questions. If you have any comments, please you can leave them on the Reddit thread or on the YouTube page. And point out all the things that I am doing wrong. And if I'm over explaining anything, which I definitely am, please tell me. If I'm under explaining everything, which I definitely am, again, this is my first time doing any sort of tutorial. I don't know what you don't know, and I'm kind of calibrating it to my past self that struggled with Rust. So anything I struggled with is going to be explained 10 times. Anything that was easy for me, I'm not going to explain at all. So please, for the love of God, explain something. Tell me what I'm missing. And or for example, if you wanted me to do a vec atster, which is slightly more efficient, I will gladly do it. But for now, I mean, later on, I'm going to turn it into iterators, so I don't think it's that important at this point. Yep, thank you for your time. Thanks for watching.